In this lesson, our goal is for us to be able to find the distance between 2 points. We are continuing on with the lesson that we talked about yesterday, and we are just going to be taking this a step further. So just really quick, we are going to review with a few words. We ended with the segment addition postulate last time, and I want to just remind us what that was. The segment addition postulate was if we have a line segment. Remember, line segments have a beginning and have an end, and they have a length, okay? So if we have a line segment and have another line segment within, so we have a line segment here that goes to the purple dot, and then another line segment that goes from purple dot to the red dot. Let's go ahead and name that. Let's call that A, B, and C. We have a line segment AB. We have a line segment BC. And AB plus BC equals to the total length of the line segment. So in other words, segment addition postulate, if we have AB plus BC, the two smaller segments equal the larger segment, equals AC. That is a segment addition postulate. Also, just a quick reminder, when we are writing it in an equation, we do not have to put the lines over the segments because we're talking about a specific length. If we are talking about the shape or the line segment in general, make sure that you would put the line over top of what we're talking about. But in this case, because we're talking about a specific length, we do not need those lines. So that's our segment addition postulate. We talked about that yesterday. We are going to talk about the distance formula in terms of a number line. So if we have any generic number line, okay, any generic number line, and let's put a few numbers on here. Let's say that we have 0. Let's say that we have 1. Let's say we have 2. Let's say we have -1. Let's say we have -2. The distance formula for a number line. Let's just take two numbers. Let's say we have point A at -1 and point B at +2. The distance between A and B in this case is going to end up to be 3. That is the distance. The formula for this is going to be the absolute value of, we are going to do x1 first, or x2. It does not matter which one we choose first. We can do x2 minus by x1, and that is our distance formula. You may be like, how is that the distance formula? Let me show you with this example. Let's choose B as our x2. Okay, we're only dealing with the x1, x2. So let's say 2 is x2. And let's say -1 is x1. This is absolute value of the second one, which is 2, minus by the first one, which is -1. So minus the negative is a positive. Remember, this would become a positive. And 2 plus 1 gives us 3. Absolute value of 3, 3. By the way, if we did it the other way, if we did absolute value of -1 minus by 2, that gives us absolute value of -3, which is, again, distance of 3. Okay, so that is the distance formula if you have a number line. Okay, well, what if it's not a nice horizontal line? What if the line has a slope to it? What if it is diagonal? Well, that gives us the distance formula on the coordinate plane. Let's just quickly remind ourselves what the coordinate plane is. The coordinate plane is our x and y axis. Okay, remember the x-axis is our horizontal line. The y-axis is the vertical line. That's our coordinate plane. We have the x values, we have the y values. So if we were to have a line segment that looks like this, using this formula, we can now find the distance between those 2 points. Okay? Here's the distance formula in terms of these points. We are going to do it this way. We are going to say that this is going to be, let's go with saying this is A, this is B. We're going to say that the distance from A to B equals to the square root of parentheses. This is going to be x2 minus x1 quantity squared plus y2 minus y1 quantity squared. You may look at that and be like, what in the world? That looks insane. How am I ever going to remember this? Here's how you're going to remember it. Pythagorean's theorem. Pythagorean's theorem is really just a distance formula. Let me show you. If we were to take this line segment AB, and let's extend these lines, let's make this so that this is a horizontal line here and this is a vertical line here. We have now created ourselves a triangle, right? And this triangle has side lengths. One side length, we can call this side length A, and we can call the other side length B. Let's use lowercase b. Okay, and let's call this long side the hypotenuse. Let's call this side C. Okay, we're going to call this side A, side B, side C. All of these have a certain length. Remember, Pythagorean's theorem gives us that A squared plus B squared equals to C squared. Okay, A squared plus B squared is C squared. That is Pythagorean's theorem. Well, if we're finding distance, we're finding the value of C. What I'm going to do is I'm going to use our symmetric property of equality, and we're going to rearrange it as C squared equals to A squared plus B squared. And what we're going to do from here, if we wanted to get C alone, all we now have to do is take the square root. So C equals to the square root of A squared plus B squared. Remember, A squared, A and B are distances. A and B are distances. So what this distance formula over here is saying is that we are finding the distance from the x2 to the x1. How far is that? We're going to find the distance from the y to the y1. We're going to square those, add them together, take the square root. We have it. Distance formula is just Pythagorean's theorem. Just rearranged just a little bit. And the way that I'm going to do it in the video is I'm going to just do the Pythagorean theorem way. I'm going to show you how that works, show you the quick method. I do have other videos attached to the webpage that has explanations for how you would actually use the distance formula, the long way. But I'm going to show you the quick way with this. Just a quick reminder, Pythagorean's theorem, just a quick reminder, a theorem is a statement that has been proven. It is proven to be true no matter what. Using definitions, postulates, another word for postulates is axioms, and previously established theorems. Okay, that's just a side note, just a quick reminder of some other words we had. Okay, so let's actually go through some examples of how this works. Use a number line to answer the following questions. We have this number line here. We have some points on this number line, and we want to find the distance from A to C. The distance from A going to C. Okay, well, A going to C, we know that A is right here. We know that C is over here. How far is negative 10 from negative 7? The distance of that, we can go, well, this is absolute value. Let's say C is the second one, so negative 7 minus by negative 10. So this is absolute value of negative 7 plus 10. And negative 7 plus 10 is really 10 minus 7, which is 3. So absolute value 3, which gives us distance of 3. By the way, we can do it another method. Negative 10 and negative 7. Just think about the numbers themselves. How far is 10 away from 7? 3. So we don't even have to do the formula. We can just think about it in our minds and naturally get to the answer. Now remember, if you have one of them that's negative, one of them that's positive, quick little hint. If one's negative, one's positive, you're going to add those values together. Just add the numbers. So if it was negative 10 and 1, we just go 10 plus 1, 11. Done. Okay? If they're both negative, we are going to end up subtracting. So 10 and 7, 10 minus 7, 3. If they are both positive, subtract. So if it was 3 and 1, 3 minus 1, 2. Okay, so that's just a quick hint on how we can do this quickly. If they're opposites, add them together. If they are the same, subtract them. Okay, part B. Determine whether line segment AD and line segment CF are congruent. Remember, congruent means that they have the same length, at least in terms of a line segment. Okay, so A to D. Let me go ahead and get rid of that. A going to D. A to D is negative 10, and we have negative 3. They're both negatives, so let's go ahead and just subtract. 10 minus 3 is 7. C to F. C to F. They're opposites, so let's add them. 7 plus 1.
6.
7 plus 1 is 8. We are going to add them. Remember, opposites add, the same ones subtract. Are those the same number? No. So these right here are not congruent. Okay? So determine congruency, figure out the distance. So that's how you do it in terms of a number line. Let's do another example of some other stuff. We're going to work on the coordinate plane now. We had the number line examples. Now we're going to work with coordinate plane. I'm going to show you how to do this without having to graph it. Okay? So we have, find the distance between each pair of points. We have point A, which is 3, negative 2, and B, which is negative 1, 5. Again, I'm just going to show you the quick way of doing this. How far is 3 from negative 1? Well, they're opposites, so we add them. 3 plus 1, 4. How far is negative 2 from 5? Well, they're opposites, add them. 7. Let's just use Pythagorean's theorem. We're finding the distance, so we're trying to find C. Square root. Distance of the x values is 4. Let me use the color that I used, 4 squared. Distance of the y values, 7 squared. That's all it is. Okay, so from here we have 4 squared, which is 16. 7 squared, which is 49. Let's add those together. So square root of, this would end up be 65. Okay, square root of 65. That is not a perfect square. So this is what we call an irrational number. Okay, so this is not going to be a nice number in the end. Irrational numbers cannot be written as fractions, by the way. If we wanted to find the decimal version of this, this would end up to be about, and you will be using your calculator for finding the decimal version of this. This would be about 8.06 going on forever. Okay? It does not end. Whenever I'm asking you to do a problem that has us do one with an irrational number, I do not want you to put it as a decimal. I want it written as a square root. Okay, I want the exact value, not an approximation, because the minute we round, we have an approximation. Okay, so whenever I'm actually looking for an answer, I'll be looking for that. Okay, part B, Pythagorean's theorem. Let's do this the same way. X's, how far are 2 and 5? Or how far is 2 and 5? Well, they're the same being positive. So we just subtract. 5 minus by 2 is 3. And we always take this bigger one minus by the smaller. Okay? Then 0 and 4, well, 0 to negative 4, that's just distance of 4. So same thing, we're going to do C is equal to square root of 3 squared plus 4 squared. So this would end up being square root of 9 plus 16. 9 plus 16 is square root of 25. 25 is a perfect square. Square root of 25 gives us the answer being 5. And that is the answer that I would be looking for. So whenever you're solving for distance, whenever you're given 2 points, just use this method. This method is the easiest method versus actually doing the distance formula. The distance formula is great, but if you truly look into it, it's just Pythagorean's theorem. Let's look at a few real-life examples. Okay? Here's an example. After school, Ben walks to the library. which is located at point 3, 7 on a city map. His friend Luis walks to the basketball court located at 12, 7. If each unit on the map represents one block, how many blocks apart is the library and the basketball court? Okay, so we're just looking for the distance. And we have a coordinate point for each of these. So here's what we're going to do. We are going to just take each point. We have 3, 7, and we have 12, 7. And let's find the distance. Okay, well, how far is 3 from 12? Those are both positive, so subtract. 12 minus by 3 is 9. 7 and 7, those are the same exact value. That'd be 0. So in other words, the distance, C, is square root of 9 squared plus 0 squared. Wait, square root of 9 squared plus 0 squared is just 9 squared. Right, 0 squared is 0. Square root of 9 squared is just 9. It just undoes the square root. So the library and the basketball court is a total of 9 blocks apart. Okay? That's how simple this is. We just have to remember Pythagorean's theorem, plugging in the numbers, finding the distance of each of those points. Here's another example. During practice, a basketball player is standing at the 3-point line, which is at point -4, 6, at least in this situation. Okay, the coach probably made a grid. That's where he placed the 3-point line on the coordinate grid. The hoop is at the origin, meaning the center of the graph. How far is a player from the hoop? Oh, we're just finding the distance. Remember, the origin is 0, 0. That is the beginning of the graph, whenever x is 0 and the y is 0. So we have -4, 6 and 0, 0. This is one of the easiest ones for finding distance. -4 from 0 is a distance of +4. We cannot have a negative distance. And 6 to 0 is distance of 6. Okay, well, in other words, distance formula, Pythagorean's theorem, we're going to be using it simultaneously. Square root, 4 squared plus 6 squared. By the way, doing it this method, it does not matter which one goes first. We could put the 6 squared first or the 4 squared first. It does not matter. Addition is commutative, meaning it does not matter which one you put first. Okay, 4 squared, 16, 6 squared, 36. Add those together. This is the square root of 52. Okay, square root of 52 is not a perfect square. However, it can be simplified. We want to simplify our square roots. So just a quick lesson on simplifying square roots. 52, let's look at 52. 52 has certain numbers that can multiply into it. We know 2 can go into 52. We know 2 can go into 52. And that would end up to be 26 times, right? Okay, 26, 2 can go into 26. So this would be 2 times 2 times this would be 13. By the way, we could have saved ourselves a step and recognized that 52 is really 4 times 13. Okay? So putting it back into our square root, we have 2 times 2 times 52. Okay? We have 2 of the 2's. If we have multiple of the same number, we release one from jail and leaves the other one in prison. Okay, we release one from the root, we leave the other one, where we release one from the root, and then the other one just goes away. Okay, so here's what we end up with. We have 2 2's, square root of that, put one of them outside, the other one goes away, and we are left with the 13. By the way, I wrote down 52. Make sure that we write down what we say. This should be 13, not 52. So since we have 2 of the 2's, one of them goes out, the other one disappears. And then we're left with that 13 because it's not a double of the 13. Okay? That is fully simplified.